Bismillahirrahmanirrahim. Assalamu alaikum. My name is Numan Ali and my father's name is Muhammad Osama Afridi. Today the topic of our lecture will be location tracking and or positioning. You can see our content of presentation. So we will start with the introduction, defining the location tracking and then some of its application. After that, we will define different types of positioning systems, then some basic method or techniques that are used in position tracking, followed by some positioning systems like GPS, and then we will end the presentation there. Uh, so the first question is, what is position tracking? Position tracking or location tracking can be defined as the process of determining the position of a target mobile relative to a fixed location or absolutely in a certain coordinate system. Here you should focus on the term target mobile and the base stations. Target mobile are those objects or devices whose location is unknown and we are interested in finding its location. While the base stations are those devices or objects whose locations are known. Either they can be static or dynamic. If they're static, then we know the exact fixed location in the coordinate system. If they are dynamic, then they must also use some kind of positioning system to locate themselves in certain coordinate system. But the point is here that base station's location will always be known in our discussion. So after what comes why? Why should we learn about location tracking? Well, because location tracking has been an important topic of research since World War, and there are many different positioning systems are developed, and still they are being developed. So it has numerous applications in defense systems where we have to detect the missiles and aircraft. We use location tracking. In autonomous vehicles, the vehicles need to know their exact location on the map in order to perform correctly. While in law enforcement, they use to track persons vehicles they use to track mobiles, etc. And finally, in route selection, we all have used Google Maps to find a destination, so it is very convenient because it uses the GPS. So now we define some types of positioning systems. Since there are vast number of systems, so we categorize into them into different types. So the two main types are global positioning systems and local positioning systems. In global positioning system, each target makes its location absolutely in a certain coordinate system, while in local positioning system, uh, the target makes its location relative to some other fixed point or base station. Uh, then it can be divided into two types. Self positioning systems are those which require initial location. Like we give them initial location, and then based on their sensory inputs, they track themselves relative to their initial location. While in remote positioning system, the target depends on base stations, and it makes its location relative to those base stations. This can be further divided into two systems: active or passive systems. Active systems are those in which the target actively participates in the process of positioning, while in passive system the target does not cooperate with the base stations to help them in finding its location. So before we move on to the positioning systems, there are some basic methods that almost all the positioning systems use. So these are the time of arrival method, time difference of arrival method, receive signal strength, and detection of arrival. In these methods, we assume one thing, that there's a target here and there are certain base stations there, here, or somewhere else in exchange, and the target emits a signal that is known to base station. So this signal will reach also here, 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 and here. Based on the time and the direction of this signal reaching the base stations, we move the location of the target relative to these base stations. So let's move on to our first technique, that is time of arrival technique. If we again consider the example that I said, if the target is here and we this time assume that it is a 2D system, so it will have coordinates x and y. So this target is located at x and y, and there is a base station I, base station at x I y I, and there is another base station j x j y j, and similarly there is another kth base station. So when the target emits the signal from target reaches this figure, we call it the time ti. When this reaches this, we call it time tj. When it reaches this, we call it time tk. Okay, so this target emitted the signal at time tm, and the time taken by the signal to reach here is could be tpi, tpj, and tpk. So we can write an equation here, like if ti is the time of arrival of signal at the ith base station, then it will be equal to tpi plus tm, the time at which target transmitted the uh, signal. So in this kind of technique, we assume that we know tm. Although knowing tm is very difficult, but we assume that we know tm. So if we know tm, then we can take it into right hand side, and ti minus tm equals to tpi. So we know ti, the time at which the signal was catched by this base station, and the time tm we assume that we know. So we know the propagation time of the signal. So using the formula distance over speed, since these are electromagnetic waves, so they travel with the speed of light, so c, and this is the distance. So we know in 2D plane the distance formula is the x minus xi square plus y minus yi square divided by c. So we get one equation from the base station I. So this equation has two unknowns x and y. All other quantities are known. So we cannot find an unique solution for the x and y. So we will incorporate another base station, which is base station j, and we will similarly write its equation. It would be dj divided by c equals to similarly this system. So we have two equations and two unknowns. This system is solvable, but when in general, when we solve this equation, we get two solutions in general. So in to avoid uncertainty, we need to pinpoint the exact location of the target. So we do not want two solutions, we only want a single unique solution. So that is why we will need another third base station, the kth base station, and we will write its equation dkc equals to again this distance formula, and simultaneously solving these three equations, we get the unique solution, which is the target of the location. Uh, we can also explain this geometrically. If we focus on this equation uh, and we rewrite this equation, we can rewrite this equation as x minus xi square plus y minus yi square. This is equals to c dpi square. So if you remember, this is the equation of a circle with the radius this, and the center of the location is center of the circle is xi and y, that is the base station. So again, if in Cartesian in 2D system, when we draw this, if the target is here over x and y, and the base station is ith base station is here, so it will form this circle like this, a big circle. So this circle is the solution of this equation, and it tells us that target can be at any point on this circle, but we need to pinpoint the circle. That is why we add another equation from the jth base station as previously explained. So if jth base station is here, so this circle will be formed like this here, and since I said there will be two solutions if we use two equations only. So this is the other solution, that is inaccurate solution. So we do not want that. So that is why we introduce another base station kth. We could do somewhere here, and this will, so the three circles will intersect at a single point in case there is no error in the measurements. So that's how we get pinpoint the location of the target. We can also see this with an example. If you assume that there is a base station here, and at this point we see the left picture this. So when we solve the equations for these two base stations, we get these two circles and they intersect at this point and this point. So there is uncertainty which point is to be used. So what we do is that we introduce a third base station here, which is there, and the three circles meet at a single point and we exactly pinpoint the location. So there are some complexities associated with this type of system. The first one is the transmitted signal must be labeled with a timestamp in order to allow the base nodes to determine the time at which the signal was initiated at the target node. This additional timestamp increases the complexity of the transmitted signal and may lead to additional sources of error. So we assume that Tm is known. So if Tm is known, then we have this problem in order to know Tm. Similarly, if we need to know the Tm, the target clock must be synchronized with the base station's clock precisely. And if there is even an error of 1 microsecond between these clocks, then it may generate a error in a distance of 300 meters, just 1 microsecond. And the third problem, that is the location of base station must be known. So this would be problem of for uh, all the systems that we're going to discuss. So let's move on to next technique. So next technique is time difference of arrival. It is similar to that of TOA, in which we measure the time of arrival of the signal, but in this case we do not know the information of Tm. So if I write that equation again for the ith base station, so we do not want the complexities associated with Tm. So we do not know Tm in this type of system. So what we do, we have another base station Tj equals to Tpj plus Tm. Since these both equations have same Tm, the signal was transmitted from the target at same time. So we can subtract these two equations, Ti minus Tj equals to Tpi minus Tpj. So this equation becomes independent of Tm. And now if we again use the distance technique, Tj dot by c. So in b and I there are two unknowns x and y that is associated with the same base station and target location. So we have one equation, this difference equation, and two unknowns. So we will need another equation. So we introduce the third reading from the third base station, that is Tk, Tpk plus Tm. This. So if we write Ti minus Tk equals to Tpi minus Tpk equals to Di minus Dk by c. So now we have two equations and two unknowns, and depending on the information that we receive from the target, we can exactly pinpoint with the help of these two equations. You might also notice that we can also make a third equation, Tj minus Tk, but this equation will be dependent on the previous two equations, is not independent. So let's use geometry with the help of an example. So if we see this difference equation, and we also expand this in di's and dj's. So what we get is this some form of equation like this: x square divided by a minus y square divided by b equals to 1. So this is an equation of a hyperbola. So similarly, in this example, if we place the base stations here, so the hyperbola comes out to be this. Uh, this hyperbola is drawn here. You might also remember that hyperbola has two sides. So why are we not drawing this side? Because we have the information that the this base station observes a shorter distance. This base station. So this side will always have a shorter distance for this base station. That's why we do not need to uh, include this side of hyperbola in our calculations. So simply we can tell that it must be the target specification is on this hyperbola. So now if we add the third base station for k, so add we equation for ti minus tk, so we get another hyperbola. This so it will intersect this at a single point and we can pinpoint the target's location. But that is not always the case. If we look at this example where the base stations are located at these points, and when we solve the equations we get the hyperbola like this, and they all intersect at 2 points. So that is why we cannot exactly pinpoint the target's location and there is uncertainty. Therefore, we will need a fourth base station uh, to exactly pinpoint the target. Uh, so if now we compare the TDO versus TOA, we see that TDO does not require a TM. So that was the clock of the target must not be synchronized with the base stations, need not to be synchronized with the base stations, but the base stations clocks must be synchronized. Also, the TM not knowing TM eliminates the complexity of having a timestamp with the signal, and but it might cost us to have a fourth base station to acquire a unique solution for the target's location. Uh, Next technique is the direction of arrival technique. In this method, the receiver need to know the direction where the signal is coming from. So we discuss this in detail here. So let's assume our target is here at this point, and there is a base station here and here. So when the target emits a signal, these base stations are emitted with directed antennas, and they will definitely get the signal and know that the signal came from this side or this angle. We call these angles alpha and beta. And since we know the location of base station, so we can calculate the distance of B here. So since we know there's two sides of triangle, two angles of triangle, and on side of triangle, we can also find these sides A and B or C actually using the law of sines. So in this way, we can exactly pinpoint the location of the target. But this kind of method is very prone to error since because we do not have a antenna that directs and signal from a straight line. So the antenna covers some sector of the area. So this base station will be covering this side of antenna. So this whole thing would be a part of the possible locations of target. So this is not a very accurate method, but what its benefit is that there are two base stations only required. So the same thing I have here written is that it requires it calculates the distance through angles, location of target through angles. Base station should be equipped with, but base station should be equipped with the antenna arrays, and each antenna array should be equipped with the radio frequency front end components. However, this incurs high cost, complexity, and power consumption. So this kind of method is very not used alone. It is used with the TOA method combined with TOA method to get a proper to work to make it work properly. And unlike TODA, it only needs two base stations as I said before. So the next technique is the received signal strength based location tracking. So here I have written the formula of power received by an antenna, uh, by a receiver. So this power depends on many factors, including the power transmitted, the gain of the transmitting antenna, gain of the receiving antenna, then the loss at the transmitting side, loss at receiving side. This is the shadowing. This is a random error associated with the channel at which the at which in which the signal is traveling, and there is also some path loss associated with the power of the signal. And it is dependent on the distance d. So the longer the signal travels, the more path loss it incurs in it, and the lesser the power is. So based on this formula, we can also derive the uh, uh, distance of the target from the base station. Depending upon we know what was the power transmitted and what are these factors, all factors. These last two factors are they are a kind of random factors, so we have to model the channels, and there are very different techniques. If anybody of you have studied the mobile communication, so channel modeling is a whole another subject. So if we get the distance, so similarly we will need a three base stations as we needed in TOA to pinpoint a target, because since we are getting the distance, we only can mark a circle for single base station for the possible target locations. So if we compare uh, this with the previous methods, the main advantage we get out of it is that it is also useful for non-line of sight signals. The previous methods are highly prone to error if there is no line of sight of base station with target. Therefore, RSS is preferable in the environments where there are tall buildings or hills. If we talk about the accuracy, then D or A is the least accurate because directed antenna cover not only a single line but a small sector. While T or D perform well, there is a lines of sight, and RS has best performance in all cases. Talking about the cars, DOA also the most expensive method, while uh, DOA has have comparable cost and do not differ in cost as much. Then the number of base stations I have already discussed. So that's it from my side. All other the GPS and other positioning systems will be discussed by Osama. Now, thank you for listening patiently.